Hello, welcome back to our last installment of trig identities. We are going to look at the product to sum and sum to product identities today, and these are the last of those fundamental ones that you see on your worksheet and so forth. Now, there's lots of trig identities. You can dream up all kinds. An identity basically is a statement where the two sides equal each other. If you want to verify, you work with one side at a time and make sure that two sides come out the same. So we're going to look at a couple more fundamental identities, and then we'll look at a couple of examples of, well, how could you use these, or how might you be asked to use these besides problems with verifying. All right, we'll start with product to sum today. Now, in order to derive these, we're actually going to use cosines and sines of sums and differences. You guys learned these identities at the very beginning of doing this identity stuff. And we're going to use them to get an identity where you can go from a product to a sum. Alright, first of all, let's start with cosine of alpha minus beta equals, we know this one now, cosine alpha, cosine beta. But in order for cosines to be close, the minus gets sacrificed. We get a plus, sine alpha, sine beta. And then also let's take cosine of alpha plus beta. Then you got cosine alpha, cosine beta, minus sine alpha, sine beta. Well, if you take the two of these and subtract them, you get an interesting result. You have cosine of alpha minus beta minus cosine of alpha plus beta equals, well, cosine alpha cosine beta plus cosine alpha cosine beta is 2 cosine alpha cosine beta, plus sine alpha sine beta, then, oh, I'm sorry, we're subtracting. Subtracting, pay attention to your signs, don't make that same mistake that I just made. Alright, change this back to a pen. Alright, subtracting cosine alpha cosine beta minus cosine alpha cosine beta, that's going to be 0. That's going away. But if you have a positive sine alpha sine beta and you're subtracting a negative sine alpha sine beta, you're going to end up with a positive 2 sine alpha sine beta. Now we want to get an identity that takes us from a product to a sum. Well, right here is a product, and right here is a sum. You might be going, Ms. Schofield, that's a minus. Remember, addition and subtraction are inverses, so subtracting is like adding the opposite. So you can still call it a sum. To clean this up a little bit, divide both sides by 2 so that sine alpha sine beta is all by its lonesome. There's your product. And it's going to equal 1/2, because you divided both sides by 2, times that cosine of alpha minus beta minus cosine of alpha plus beta. And there we have it. There's our first product to sum identity. The other three are derived in the same kind of way. We can take these two, and instead of subtracting, we can add. So we can take cosine of alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. And we can add that with cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. This is what I had been trying to do earlier when I was supposed to be subtracting. So if I add them, I've got cosine of alpha minus beta plus cosine of alpha plus beta equals 2 cosine alpha cosine beta, and then the plus sine alpha sine beta and the minus sine alpha sine beta ends up being 0. So make sure this is a product to sum. Divide both sides by 2 so that cosine alpha cosine beta is nice and clean there. And that equals 1/2 times cosine of alpha minus beta plus cosine of alpha plus beta. And there's another one of your product to sum identities. Woo. Now take your sine of alpha minus beta, sine of alpha plus beta, and work with those, and that can get you 2 more. Let's say you have sine of alpha plus beta. That equals sine alpha cosine beta plus cosine alpha sine beta. And let's say we add that with sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. So then you got sine of alpha plus beta plus sine of alpha minus beta equals, you end up with 2 sine alpha cosine beta. Divide both sides by 2 and you have your product to sum. Sine alpha cosine beta, that's your product, equals 1/2 of sine alpha plus beta plus sine alpha minus beta. So there's your third one. Woo. And if you guessed that we would do this procedure again and subtract this time, you guessed correctly. Sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. And this time we're going to subtract sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. So we have sine of alpha plus beta minus sine of alpha minus beta equals 2 sine alpha cosine beta. No, because we're subtracting. So these go to 0. Minus 2 cosine alpha sine beta. Divide both sides by 2. You have cosine alpha sine beta equals 1/2 times sine of alpha plus beta minus sine of alpha minus beta. And there's your fourth of these identities. Okay, so there you have it. There's your product to sum identities. So now, if you're asked to take something like sine of 5x, sine of 2x, and rewrite that product as a sum, you can say, well, I know that sine alpha sine beta equals 1/2 times cosine of alpha minus beta minus cosine of alpha plus beta. So what I can do is say that sine of 5x sine of 2x equals 1/2 times cosine of 5x minus 2x minus cosine of 5x plus 2x. So it equals 1/2 times cosine of 3x minus cosine of 7x. Now you've taken this product and rewritten it as a sum. Okay, so the next identities are the sum to product identities. So let's derive those, and then we'll see an example or two maybe of how to possibly use them. Alright, we're going to take some of our product to sum identities and use those to develop the sum to product. You know, it makes sense that if we're going backwards, earlier we went product to sum, if we're going to go backwards, sum to product, maybe we can use those to somehow do this. Alright, let's start with the fact that sine alpha cosine beta equals 1/2 times sine of alpha plus beta plus sine of alpha minus beta. Let's let A alpha equal x plus y over 2 and beta equal x minus y over 2. Alright, so we got sine of x plus y over 2 cosine of x minus y over 2 equals 1/2 sine of x plus y over 2 plus x minus y over 2 plus sine of x plus y over 2 minus x minus y over 2. Okay, now let's get rid of that 1/2. Let's multiply both sides by 2. That side 2 times 1/2 is 1. And let's clean things up a little bit too. We have sine, well, x over 2 plus x over 2 will be 2x over 2, or x. Y over 2 plus negative y over 2 will be 0. So we end up with sine x plus x minus x will be 0, y minus negative y will be 2y over 2, which would be y, so plus sine y. And there it is. Sine x plus sine y equals 2 times sine of x plus y over 2 cosine of x minus y over 2. There's that one. Let's see, and if you replace y with negative y, sine of negative y equals negative sine y. If you do that, then you can do sine x minus sine y equals 2 times the sine of x minus y over 2 cosine of x plus y over 2. So replacing y with negative y. And you get that one. Alright, and then let's use the fact, let's see, earlier we used sine times sine. Let's use cosine alpha cosine beta equals 1/2 times cosine of alpha minus beta plus cosine of alpha plus beta. Let's do that procedure again where alpha is going to be x plus y over 2. Beta is going to be x minus y over 2. So you have cosine of x plus y over 2, cosine of x minus y over 2 equals 1/2 cosine of x plus y over 2 minus x minus y over 2 plus cosine of x plus y over 2 plus x minus y over 2. Multiply both sides by 2 also. You got 2 cosine of x plus y over 2 cosine of x minus y over 2 equals, and 2 times 1/2 is 1. Then cosine, let's see, x over 2 minus x over 2 would be 0, but y over 2 minus negative y over 2 would be 2y over 2, or y, plus cosine, here we're going to end up with cosine x. So cosine x plus cosine y equals 2 times cosine of x plus y over 2 cosine of x minus y over 2. So there's that one. And then to get the other cosine one, we actually need to work with sines and so forth again. I know it sounds weird, but we actually do. To get the other cosine one, we need to start with sine alpha, sine beta, or sine alpha, sine beta equals 1/2 cosine alpha minus beta minus cosine alpha plus beta. We need to make our substitution again. So we have sine of x plus y over 2 sine of x minus y over 2 equals 1/2 cosine. Well, if you're taking these two and subtracting them, you're going to get cosine y minus cosine. If you're taking these two and adding them, you're going to get x. Multiply both sides by 2. You got cosine y minus cosine x equals 2 times sine of x plus y over 2 sine of x minus y over 2. You also might see, written a little differently, you might see them multiplied by -2, so that you end up with cosine x minus cosine y equals -2 sine of x plus y over 2 sine of x minus y over 2. So there's yet another one of the formulas. Okay, so how might you use one of those? Well, you might be given something like this, sine of 7x plus sine of 3x. You might be asked to rewrite that as instead of a sum, write it as a product. Well, let's see here. Looking at our identities, what can we use? Use sum of the sines. We're going to get 2 times the sine of 7x plus 3x over 2 cosine of 7x minus 3x over 2. So 2 times the sine, 10x over 2 is 5x. Cosine 4x over 2 is 2x. So you're able to take it from a sum to some kind of product. Right. Let's also do one where we verify an identity. I think those are fun. We need to, you gotta have plenty of those in your homework. Let's say you're given a problem like cosine 3x minus cosine x over sine 3x plus sine x equals negative tan x. You're asked to verify this identity. Well, the negative tan x side is already pretty simplified, so I don't really want to work with that. Whereas the left side here, you've got a difference and a sum. I think we can do something with that using some of these identities we now are familiar with. Let's see, at the top we have a difference of cosines. So we learned that cosine alpha minus cosine beta, we learned what to do there. Or cosine x minus cosine y. Cosine 3x minus cosine x, we're going to rewrite that as negative 2 sine of 3x plus x over 2 sine of 3x minus x over 2. Maybe this will get us somewhere. Then on the bottom we have a sum of sines, so we can rewrite that as positive 2 sine of 3x plus x over 2 cosine of 3x minus x over 2. This is just using our identities. So using the identity for the numerator, using the identity for the denominator. Alright, negative 2 over 2, that's just negative 1. So sine of 3x plus x over 2, sine of 3x plus x over 2, those are going to reduce to 1. So that reduced to negative 1. So that leaves us with sine of 2x over 2, or x, over cosine x. Well, sine over cosine is tangent. So now we have verified the identity using some of our other identities that we have learned. Once you've developed a formula, you can use it from then on. Or once you verify an identity, you can use it from then on. Okay? Alright, so that's all I have for now with the identities. Thank you for joining us. Make sure you get lots of practice. You're only going to get good at this identity work by doing lots and lots of problems. So make sure you do lots and lots of practice. Thank you again for joining us.